Right, good morning, everyone. Welcome to this BCO webinar, Design for Performance, Lessons from Down Under. Hopefully everyone is got a good connection today. We've got a great webinar for you. Just to set a bit of context and introduce myself, my name is Neil Purnell. I'm Head of Design, Innovation and Property Solutions at Landsec. I also chair the BCO Technical Affairs Committee. We've got a great webinar for you today talking about the performance of offices. As you know, the BCO is dedicated to striving for best practice in office design and in future operation of workspace across the UK, and also influences design right across the world. And today, I think we're being influenced by another part of the world, down under in Australia, where the energy scheme called the Neighbours Energy rating scheme has been in operation now for probably, I think, since 1999, I believe, and has made great inroads into reducing carbon emissions in that marketplace. The Neighbours energy rating measure actually verifies energy use in offices, both new and existing offices, and provides a rating of 1 to 6 stars to help owners to really understand how their building is performing. And what is really important here is it's measuring actual performance in use, as opposed to a lot of the current ratings on buildings are based just on a mandatory performance standard, but doesn't actually give you the information you really need to drive your building to high levels of performance. And I think we're all aware how important that is as we strive to achieve the net zero carbon targets that we're all working towards for 2050. And I know that perhaps many people on this call represent organisations who set their own targets to get to that point with their buildings ahead of that time. And I think that the Neighbours UK scheme and the Design Performance Initiative that lies behind that we're going to hear much more about today, will be a great system for us to use to drive performance of buildings forward. The approach is being pioneered in the UK based on the Australian system, but creating it in a form where it suits our own marketplace by a number of major UK property owners. And we're going to hear both from people representing that interest group who are getting to grips with this new approach, but also from the learnings from the Australian market. And we're very pleased to have guests on the webinar today that I'll introduce later as we go through. So I think that's probably enough from me as an introduction. I'd like to move now to our first speaker today, and that is Christopher Bottom from the Better Buildings Industry. Chris has been involved in overseeing the delivery of the Neighbours initiative, the Neighbours UK initiative in the UK. He generally manages the work programme for the Better Building Partnership, and he will take us through all the work that's really culminated in the launch at the beginning of this year of the scheme into the UK. So without further ado, I'll hand over to Chris. Thank you.
Great, many thanks, Neil. Good morning, everyone. I'm just going to give a quick 10-minute introduction into the work in developing Neighbours UK and provide a bit of an overview in terms of how that scheme operates and can be used before we get into the more interesting discussion in how actually this will look in practice, and hear from those within the industry who are looking to use this and that experience from Australia. But just to kind of a bit of scene setting this context, we know in the UK that there's a well-evidenced energy performance gap between the way that offices are designed versus how they actually consume energy in operation, as demonstrated by this chart here, which shows actual operational energy intensity for office buildings in the UK banded by their EPC rating. And as you can see within each EPC rating, there's a huge range of operational energy intensities, and as you can see that the averages across each band is pretty much the same, showing essentially there's no correlation between operational energy performance and their EPC rating. And for those that kind of that know the technical detail, that should come at no surprise. EPCs aren't taking on board unregulated loads and so on, but it's more the danger of how it gets used and perceived by the market, the assumption that EPCs do relate to good operational energy performance, and that's certainly not the case. And essentially, because we're not looking at the correct performance metric, we're looking at kind of design intent parameters rather than actually how do buildings perform in use. as an industry, we generally have a lack of visibility around how buildings actually perform, and that results into a lack of accountability in terms of driving that performance improvement. Who's responsible for that? Is it the tenant or is it the occupier, based on central services and systems, which has then resulted in a kind of lack of drive to then improve that over time. And so that's what this project has all been about in terms of our Design for Performance initiative, trying to look at solutions of how to overcome this energy performance gap. And we essentially looked for international best practice, came across the Neighbours energy rating in Australia. And this has been going on for a number of years now, that we looked at a feasibility study, kind of desktop research, to understand how the scheme works in operation, what are the key success factors, then try to pilot that on a number of our members' development pipelines to understand, well, could this scheme potentially operate in the UK? There's more to read if it's of interest. The short answer was yes, it's very much needed in the UK. And then over the last 18 months, we then worked to actually, in collaboration with Neighbours, to try and bring Neighbours to the UK. And essentially that's what we did. Towards the end of November last year, we launched Neighbours UK, and I'll just touch upon that, what kind of that actually looks like and what we've launched. But it's essentially an operational energy rating for offices in the UK. And this scheme is owned by Neighbours still in Australia. They own all the intellectual property for Neighbours UK, but it's administered by BRE in the UK. So there's a license agreement between Neighbours and BRE for BRE to be that operator in the UK and run the day-to-day management of the scheme, be responsible for certification, for training accredited assessors and so on. And then as the BBP, we've been involved in developing the actual scheme infrastructure, and developing all the technical guidance and so on, but then that's been handed over to BRE to manage. But we're still involved in the ongoing governance of the scheme by essentially being scheme ambassadors and promoting it and working with the industry to ensure it meets the needs of what we're looking to achieve. But in terms of what we've developed, is essentially two market offerings. There's one, Neighbours Energy Ratings, and this is an operational energy rating for existing buildings. And then there's Neighbours Design for Performance. And this is the framework or the process whereby developers target a Neighbours energy rating at the design stage for a new build or major refurb, and then the process that you go through to try and ensure that you actually meet that target operational energy rating as you go through the design through to completion into operation. And I'll touch upon these in a little bit more detail. But essentially, the Neighbours rating scheme uses a very simple 6-star rating scale to demonstrate how efficiently a building and office is being run, 1 star being poor, all the way through to 6 stars being market leading, and provides a very simple metric KPI for a range of different stakeholders involved in real estate investment and used to understand how that building is performing. But Neighbours energy ratings, as Neil mentioned, is very much taking metered energy data of the building and allowing a fair comparison and assessment of how that office building is performing. And it allows a fair comparison based on essentially the energy scope that is actually rating. And this is a really important point to understand, in that we're looking at base building energy performance in terms of the assessment criteria that we're looking at. And this is all the energy associated with the blue shaded area of this diagram. So it's all the energy associated with whole building HVAC, lifts, common area, lighting and power, hot water, but it's essentially excluding all occupier lighting and small power. And the reason this is important is that it allows buildings to be compared on essentially how they're running the central services to the occupier and conditioning that space. It allows different offices to be compared with one another, irrespective of the occupier uses within those buildings. It allows owners to be able to use it as a procurement KPI for property management services, used for marketing material to attract occupiers to the space, and to communicate to investors how those buildings are performing. That's not to say we should ignore occupier energy consumption. It's a really important part. It represents a good 50% of the energy consumption in the building. So whilst we've just launched a base building energy rating for the time being, it's very much planned that we'll move to developing a whole building and tenancy ratings later this year, as already operates in Australia. But first off, we wanted to take it one step at a time and focus on base building energy ratings. So that's the operational energy rating, but then there's also Neighbours design for performance. And this is the process whereby the developer targets that operational energy rating at the start of the design stage and follows a framework through to try and deliver that. So this is essentially a very simple diagram representing that process whereby a project signs up to commit to a particular target rating, then has to undertake detailed simulation modeling, trying to predict that operational performance. So very much a different change of tack to how we traditionally look at modeling, by rather than looking at the kind of design inputs through SBEM, etc. You're very much focusing on operational outcomes, looking at different scenario analysis of how this building can be used. It goes through an independent design review, and this is a panel of experts administered by BRE that provides that independent and assurance to identify key risks and opportunities for the project team to consider, but essentially goes through the development process, construction, handover, and once you have 12 months worth of data, you get a Neighbours energy rating to demonstrate whether you met that target or not. Now, that is a very simplistic diagram of a very complex process, and there's a lot more detail within a guide to design for performance that's available online if you'd like to look in that in a bit more detail. But we're very much later today going to be talking about these steps. What are the key challenges that we need to overcome to be able to deliver this very much for the first time in the UK? And I mentioned that this independent design review panel, this was just launched just last week, and this is a panel of experts that have gone through training and an assessment criteria to demonstrate that they have the skills to be able to support the industry to share best practice and learning at a much more accelerated rate than would otherwise be able to happen within kind of individual design practices. And you'll be hearing shortly from Jen Elias at Cundall, who's successfully made the panel. But this design for performance process, this isn't just something in theory. There are buildings going through this as we speak. So we have 14 projects signed up already from the original cohort of developers that were supporting this scheme, very much London-centric at the moment, but a number of Manchester buildings as well. And Peter Williams will be talking about their Stanhope development to Ruskin Square shortly. But this is very much happening in practice, and it's now available to all projects in the UK. If you'd like to sign up, there's details on the BRE website of how to do that. And delighted, since we launched this a couple of weeks back, that we've had another couple of applications already come through straight away, which is very encouraging to see. So in terms of what's next, I'm wrapping up my side. So there are still a number of activities that we're involved in terms of bringing this to the market. Firstly, we're developing assessor trainings. So these essentially for the assessors to be able to come on site, gather all the evidence, and essentially enable a building to get a Neighbours energy rating. That should be launching towards the end of this month by BRE. And then we're also working with CIBSE to support the kind of MEP and simulation community on advanced simulation training. So what's the different approaches you need to do to understand how to model for operational performance. But so that's very much around industry upskilling. And then kind of more importantly, and what we're going to be talking about later this morning, is actually, well, what does this look like in real life application in terms of having to actually undertake the simulation modeling? What does actually that involve? What are the skills required? What are the challenges going through that contractor procurement process to actually through to project delivery for the design for performance framework? And then actually, what are the challenges and the availability of being able to get existing buildings rated? So hopefully that was a very quick but useful overview, but I will now pass over to Neil to introduce the next speaker as we get into the detail of what this looks like in practice.
Thanks, Chris. A great introduction and taking us through the great work that's been done by the Better Building Partnership to get Neighbours to this point in the UK. There is, before I sort of introduce the next section, which is a UK perspective from the experience with the pilot projects, and then that will be followed by an Australian experience where we've got two guest speakers joining us today. I'm going to finish with a panel discussion. So I intend to take questions from everyone who's on the audience at the end when we go into a panel session where we can talk through any things that you want to ask as we go through the process now. But please feel free to actually use the Q&A button as we go through, so you don't forget the questions from each section, and we'll bring them all together at the end. I think from this point, we'll now go into the UK experience, and this section is going to be a sort of discursive section, I think, between two very good speakers. Peter Williams, who is the technical advisor of Stanhope and an in-house advisor on technical matters. He's a chartered engineer, and prior to joining Stanhope, he worked with a number of multidisciplinary teams as a designer, contractor and client. His involvement with the BBP Design Performance Initiative is specifically around some of the projects that Stanhope are currently developing, and is implementing that design performance framework for the business going forward. Peter is a member of the BCO Technical Affairs Committee and was a co-editor of the BCO Guide to Specification and Fit Out. And in this section, he'll be joined by Jennifer Elias, who Chris mentioned earlier, and congratulations on making the advisory panel. Jennifer Elias is a senior sustainability and building physics engineer in Cundall in London. She has 7 years experience of working in Australia, so is obviously familiar with the Neighbours scheme. She's worked on the design, simulation and delivery of that across buildings in Australia, and is now helping us in the UK and working with a number of clients to take the DFP and Neighbours UK initiatives forward. Since going to the UK 3 years ago, Jen's focus has been on operational energy simulation, and she's as I've said, a member of the newly launched Neighbours Independent Design Review panel. So over to you. Let's hear what's been going on in the UK.
Thanks, Neil. Thanks very much for that. My backdrop might not be quite as spectacular as Sydney Opera House, but I think it represents what's best of the UK. Neighbours is very important to us as an organisation, because inevitably we want our buildings to improve, whether it's in design, construction or operation. And for us, reducing climate change is really vital for our business to succeed, as it is, for that matter, for our collaborators to thrive. And it's good for occupiers, it's good for investors, and therefore it's good for us. But I guess most importantly, we all share the same planet, so it's simply the right thing to do. In the past, there have been many other attempts at closing the so-called performance gap. But in my view, I think Neighbours is the best opportunity, it's certainly the best opportunity I've seen in my career, and the best opportunity we have to get some real life feedback. And it's arriving in the UK at the right time to receive a warm welcome when many of our peers are embracing it. Our plan is to use DFP on all of our new projects, whether our own projects or in our joint venture projects. And we have one underway that Chris mentioned, 2 Ruskin Square, that we hope will become the first new development to move right the way through the DFP process and to ultimately achieve a Neighbours rating. It's in construction at Croydon at the moment. We have a tenant lined up. The development is being procured by the Government Property Agency on behalf of the Home Office. So the stars are aligned for us to be able to build something relatively quickly and get people, a tenant on board to start using it. So we're very excited about that. But of course, what it does do, it brings to the fore some of the challenges that we're having in delivering the design for performance process, which will end up with a Neighbours rating. Just in passing, before I get into a bit more of that, we'd really like to pursue Neighbours ratings for all our existing buildings as well. Quite a few of those would need modifications to the energy metering systems to allow that to happen. But at the moment, much as we'd like to do it, the lack of occupancy during the pandemic is going to push that opportunity probably a couple of years into the future, so that we're able to collect data for the required period before we get an assessment. I think back with the DFP, the process that ultimately leads to that Neighbours rating, it's in its infancy in the UK. So inevitably, at the moment, there's a lot of focus on design and modelling. But the model's just the very start of the process as we're discovering, and there are constraints that have nothing to do with the technical design, and in no particular order. We start with a lack of data from existing buildings, so it's very difficult for us to benchmark our DFP results. There's a need to agree construction contracts that recognise the process, how this all goes together, particularly around commissioning, both before and unusually typically after practical completion. We need early appointment of building managers. We need their commitment to achieving and maintaining and perhaps even improving the Neighbours rating. And that's an area that I think Carl will talk about later on. It's perhaps unusual for us to have these building managers appointed as early as we would like to help through this process. And of course, at the end of it all, the engagement and behaviours of our occupiers is vital, and that's an element we've yet to get to closely. I think both David and Graham will have more to say about this from their long experience of neighbours in Australia, particularly the practical aspects that might not necessarily be immediately obvious. And finally, just to say back to the model I mentioned earlier, the early focus is on the model, but that's all it is. It's a model, and its predictions can be confounded by many, many things. We're still in the experimental period where no building has completed the DFP process, and we've got zero feedback. So I'm just advocating a little bit of care here, because let's remember it took Australia many years, I don't know, 10 more, David and Graham will tell us, to reach their current level of achievement. And whilst we can shortcut some things through benefiting from their experience, we won't get there overnight. And that's really all I want to say, because I want to make space for our Australian panelists to tell us more about it. But as a part-way Australian, an Australian who's over here, I'll pass on to Jen now. Jen, over to you.
Yeah, thanks, Peter. And I think I suppose what I want to share this morning is the designer's perspective on where the industry's at, and then obviously building on my experience in Australia, where we need to get to, and get to very quickly. We've already seen, even in the 6 months since Neighbours UK has launched, there's a real strength and momentum behind that in the industry, from UK Green Building Council's net zero carbon trajectory for offices, which call for offices to reach 6-star Neighbours UK by 2035. And the current consultation from BEI's Department of Business, Energy, Industrial Strategy, that's looking to make a declaration of your performance rating mandatory, potentially for commercial offices from 2023. So there's already huge momentum behind the Neighbours UK rating scheme, and obviously design for performance as a methodology. But it's important, obviously, as Peter's emphasised, that we don't let that get away from us, because there's a huge piece of work that needs to come through the UK industry to really deliver operational performance in buildings. The first one that I'd sort of flag is the simulation, sort of advanced simulation process. Look, in the UK, we have a generation of young engineers whose exposure to energy performance of systems alternatives has been pretty much via a drop-down menu in the Part L Systems Navigator. The design for compliance culture within the UK has, over the last sort of 10 years, eroded a lot of the skills that designers need to be able to deliver good simulations in the first instance, but then see that through to operation. It's that checklist level thinking that's really holding us back in the UK at the moment, and that we need to move that from a checklist level thinking to systems level thinking. Now, obviously, the design for performance review process is designed to accelerate this knowledge transfer. It's not always the best feeling, I'll say, to receive back 100 comments on a piece of work you've spent 6 months doing, but ultimately it's a good thing. And that is where we're going to have the biggest impact on the industry in the short term, providing that advice from people who've been there already to improve and develop our simulation skills and upskill the industry in that way. At the same time, we need to look at how design team scopes are defined. Over specialisation, I would say, is in some ways become endemic within the industry. What would be a traditional, perhaps mechanical design scope is broken down between a mechanical engineer, then a controls engineer, you've got your BIM coordination team, your BMS engineer, your simulation consultant, your Part L consultant, and so on and so on and so on. There ends up being scope gaps and information gaps that end up falling between each of these sort of areas of over-specialisation. We as an industry really need to invest in collaboration within the design team so that we can move to that integrated design team thinking approach that's going to deliver real solid performance in buildings. And part of that is moving into operation. We need to concentrate on closing the loop, obtaining and reviewing that performance data, as Peter's mentioned, and then learning from this in how we design the next building. And certainly, as Chris has said, the independent design review has a big role to play here, with experts drawn from both operation and simulation backgrounds to share both of those perspectives at the same time. But it's then also looking at how we scope our design team appointments to make sure that that design team engagement doesn't stop at stage 5 construction. It goes all the way through to handover and operation. Speaking from my experience in Australia, the best simulations to learn from are your own. There's no better way to learn to design better buildings than to take your own simulation results and compare them to that building in operation, fix your simulation and fix the building at the same time, and learn for the next opportunity. And then I think finally, really to echo what Peter's saying, there's no silver bullets here. There's a lot of excitement in the industry and already commitment to some really high NABERS ratings off the bat. And that's really critical to getting that momentum behind us to enable us to invest in upskilling our team, to developing, to improving, and to having those opportunities to start closing that performance gap. But it's important to realise, and that's what we're about to hear from Graham and David, that along the way we are going to make mistakes, and we need to be continuously learning from our work, learning from our mistakes, and committing to continuously building, improving, and changing the industry fundamentally over the next 5, possibly 10, possibly 15 years. And I suppose I'd just close by saying, again, there's no silver bullets here. It is a really steep learning curve, but I suppose, lesson learned from Australia is it's really important to get stuck in, to give it a go, to commit to collaborating, to sharing those lessons learned, and commit to continuously improving as an industry. And I think it's fantastic to hand over at this point back to Neil, who can introduce Graham and David, who can share the Australian experience on the lessons that we can learn.
Great, thank you both. Interesting perspectives there, I think, taken together in the round, but I think the clear message is here we need to learn, and we have a fantastic opportunity to do that now because we have colleagues joining us from Australia and both giving up their evenings, which is very kind of them to do. I'm going to start by introducing the first speaker. That is Graham Carter. Graham is Senior Technical Lead within Lend-Lease Integrated Solutions Sustainable Futures Division in Australia. He has 25 years plus experience in the design, delivery and verification of high performance, low energy building in both Australia and Canada. And at Lend-Lease, Graham has worked on some of the most ambitious projects targeting high NABERS ratings and has guided those project teams towards success. And while being humbled at the same time by real buildings that always have something to teach us on what it takes to deliver a NABERS energy rating. So I'm sure there are some interesting stories to tell, and hopefully we're going to hear about a few of those now. So over to you, Graham.
Thanks, Neil. Good morning, everyone. Yeah, just expand a bit on what Neil said there. I guess within Lend-Lease in Australia, we're quite a strongly vertically integrated property company. So there's times when we're designing with a design and construct partner hat on, and there's other times where I'm kind of advising the construction side and delivering, sometimes with externally novated designs. So we kind of get to see a pretty wide spectrum of design for performance, which has been a lot of fun and very educational over the years. First slide, Brioni. So being a engineer and working for a contractor, there's a few disclaimers and caveats on what I'm about to tell you, but I genuinely mean a lot of what I'm saying here. I think, I really think, not having worked in the UK market, that the UK can likely teach Australia a lot of things. We have fairly loose construction practices, let's say, in places, because we have a forgiving climate. And so, yes, there's things to learn, but I think there's a lot of cross-pollination that can occur here as well. I'm speaking primarily from an Australian perspective because I simply don't know your market intimately, and I would say we don't know everything. We're still learning through projects, and some of our best delivered projects from a process point of view were probably done 10 plus years ago. And I feel that's a little bit of a reflection on the challenge we have, I think, globally with consistency of the right capability to deliver for performance. Jen touched on it a little bit in the simulation community. It touches pretty much every stakeholder in our industry, and I think I'm really hopeful as we head towards hopefully being 1.5 degree aligned as an industry that we relearn and we don't lose some of the engineering knowledge that we used to have in our industry. We can do this, but we just need to scope it properly and give it a go. I think the other thing too is you look at buildings and they are incredibly bespoke products. They're not an iPhone, They're not a ship that's commissioned at dock. Every single one is slightly different, and we commission it real time. And we learn real time, and they teach us things and really embrace that, as Jen was saying. And also Jen alluded to the integration bit and the risk of scope gaps. And I think there's a balance between that and trying to make this meaningful for every discipline. It's not rocket science. And if we keep it at that level, we have a risk of losing people. So as much as possible, we need to bring Neighbours Energy back down to the level of the individual stakeholders as to what it means for them and what they can do right here, right now, and their role through the process. So I think there's a balance there between the traditional silos we have and trying to make sure they work together as a team in an integrated fashion. Next slide, Brioni. So I'm going to try and touch on, I guess, 6 aspects that start with design through to the tuning process, touching on forming the relationships. I'm going to go a little bit deep on some of the reality of simulations. I'm going to talk about metering, which I believe David will re-emphasize as well. I guess what's important from a tenant point of view and how we, I guess, protect the base building in a I guess, a fashion that is recognizing that we have buildings because we have tenants in them. So there's a bit of give and take when you do things in a way that's sensible for the whole building and bringing tenants along. I'm going to touch on procurement and commissioning a little bit and then on tuning. So next slide, Brioni. So just with the relationships, I think in Australia, we really experienced a level of almost distrust initially, where these ratings were being thrown at design and construct providers, asking them to take a risk position where they hadn't had a chance to design, let alone learn a new rating system. And that's obviously very challenging. So we had a lot of education and engagement with clients, maybe where we were seen as being a little bit difficult because we were trying to bring things back to what we can control. And when I say that, we're not trying to absolve ourselves of the end responsibility or the opportunity to realize the target Neighbours energy rating, but we do need to, I guess, assign responsibility and measure the stakeholders in a way that I guess is respective of the control that they have through the process. So I think at a very high level, a builder can commit to delivering the building as per design intent, and they can commit to going through a transparent tuning process. That doesn't mean they can guarantee the rating, because that's going to be a function of, you know, the quality of the modeling, the energy consultants' work and that. But, you know, they can deliver it as per design intent, and they should be able to commit to a transparent tuning process. If we then think about a design and construct provider who has a little bit more control around design, fit for purpose and quality, they can commit to a little bit more. And in Australia, I think we've gotten to a level of comfort over the last 10, 15 years that we can provide a conditional warrant on a Neighbours energy rating, which is subject to a few conditions, some of which are what we would call, this is a bit of a lend lease term, but tenant and owner conditions. These relate to things like we can't control the weather, we can't control how much the tenant might use the lift, so there's a lift energy budget that underpins a Neighbours energy rating. And we have to assume kind of hours of use that are sensible, tenant densities that are sensible. We have to assume the building manager will maintain things, you know, sensor calibration, things like that. So we can control a lot of things, but there's things that others still need to do to allow us to, you know, deliver a Neighbours energy rating for you. And really importantly, which I'll touch on shortly, is just, you know, it's going to be reliant on a robust estimate and prediction of performance. I think that's fine. And then I think a real point of friction that we've had is where we have external consultants, let's say working for a developer or an owner. They have a Neighbours energy prediction. They're then engaging the design and construct partner, and they're asking the energy consultant to be novated to that partner and take the risk on the energy model, which the contractor has little knowledge of. So how that is, I guess, managed is one of the trickier points. It's not perfect in Australia, but I think you have a real opportunity in the UK with the independent design review process to really embrace that, to ensure those Neighbours energy estimates are as, you know, credible and robust as possible. Take it as an opportunity to learn, as Jen said. Next slide. So I'm going to spend 2 slides. I'm going to talk about some of the common pitfalls with models. I'm going to talk about everything that's not mechanical, and then slide 2 will be all mechanical. If I can start on the right, Chris showed you a slide of the performance gap with the energy, I think, labeling scheme in the UK. This slide comes from a report that Paul Bannister from Delta Q did in with his previous employer about 14 years ago. You can see the date on the slide there. And they were looking at assessing the design capability of buildings and then looking at where they actually measured. So the design capability being in green and the actual performance in blue. And you can see a widening of the performance gap as you get to higher design potential. And this is pointing to a couple things. It's pointing to the quality of commissioning of controls, because we have a very temperate climate, and so things vary a lot in Australia, and you need to embrace that to be at the 5 or 5.5 star level. But it also pointed to the quality of simulations, where if you have a low design potential building, it tends to be fairly simple systems. There's not a lot that can go wrong. So what happens in reality can be not too far off what's predicted. But as we get to high performance, we need to be a little bit careful about the assumptions we're making. So from a building envelope point of view in Australia, we're coming from a fairly low base when it comes to things like overall U values of walls and windows. We're getting there. Building air tightness is something very new to us. I think this is probably an area where the UK is on a far stronger footing, and something that we are learning from in Australia from the UK. There's also historic weather files in Australia. A carbon conservative simulation is one that is cooling dominated. So with global warming, future weather puts ratings at risk. In the UK, you might have the reverse, but you also got to be careful of local microclimates, particularly in Australia, where we're cooling dominated. Urban heat island effects and things like that can affect things. In terms of what's assumed for the tenant and heat loading, and some of these points I'm not going to go into full detail on, but really important that diverse densities are used. The more homogeneous a simulation is with internal load assumptions and hours, the more optimistic it's going to be, and perhaps the less realistic. So it's important those are varied. And I also think that low internal loads in the UK are probably a more NABERS conservative position, which brings me to the next point, where we quite often input equipment loads into our simulation that are representative of the total tenant equipment electricity use. And we got to keep in mind that probably about half of that power use is in server rooms, which typically doesn't represent a heat gain on the base building air conditioning systems. So 7-8 watts a square meter of equipment load in modern office buildings is quite enough. And so we just need to be a bit careful that we're not assuming too much passive heat loading from the occupier's energy use that, underpredicts the heating, which will be substantial in the UK. There's a whole bunch of little things that we just don't think about. Energy consultants quite often come from a mechanical engineering background, so we don't think about vending machines and cleaning equipment and signage and things like the fire services and all the little rats and mice that when you add them all up, they can add up. One of the biggest things we found is that security sweeps and cleaning cycles can drag on till early morning hours, and that can really affect the tenant and the house lighting energy use very substantially. So the hours that we assume for lighting, we just need to be a bit realistic about what's actually going to occur in reality. I think ratings should be put together with a part occupancy rather than assuming full occupancy, at least in terms of how the potential NABERS star rating is represented. You may simulate at full occupancy, but I think you need to be assuming maybe 90% or less, because the reality is in the first couple of years, it may not be 100% occupied. With after-hours air conditioning requests, you need to be really mindful of the loop loads. You got to warm up a heating hot water loop. You got to cool down a chill water loop. And the fans are operating at a really low operating point, and actually designing for, that half floor occupancy with the systems and making sure they can turn down to that point efficiently without having to bypass air or bring on more floors is just a really important issue. In the tenant modifications to design tenant-based building systems, I might touch on that when I get to tenants later on. Before we go to mechanical, we found in Australia that the standing losses from domestic hot water systems can be circa 250% of the useful heat that's actually delivered out of the tap. Yet we're still doing recirculating systems. It's just an enormous energy drag, and at least accounting for it, if not trying to improve on it, is really important. We push electricity through wires and switchboards, and electrical consultants in Australia allow for 5% voltage drop. You might see about half of that on average. That's another 2.5%. It doesn't sound like a lot, but just all these little things need to be accounted for and not just slid into the simulation margin all the time. And we actually learned some really hard lessons about generator sump heaters that got to keep the oil at a certain temperature. Again, not often thought about, but it's really important. If we go to the next slide, Brioni, and touch on things mechanical, for those that have simulation expertise, we can model the mechanical zones of a real building, but they're perfectly mixed zones, and we need to be really careful what happens at the boundary between those zones in terms of how air mixes and UA delta T effects. You don't want that happening too quickly because it doesn't happen instantaneously in a real building. So you want to, again, and just ensure that your simulation is representative and, particularly where you got a partitioned office space. So I would encourage people to actually possibly be modeling partitioning rather than open office plans as a more conservative neighbors energy estimate. We don't think about reticulation losses that much. A mechanical engineer might think they're 1 to 2% at design point, but if you put that across the year, allow for the warm-up loads and pull-down loads, part load operation, and you're going to find it's going to be at least 20–30%, if not more, when you got zone-based systems like fan cool units. And if you got retail loads that are, operating outside the period of the office space, you just got to be mindful that the losses that occur are shared across all loads proportionately through the year. So you can't just shove all those losses to the retail tenant. They tend to have to be shared across the system on a monthly or annual basis. Duct leakage, don't forget about it. Fan and pump turn down, we had a lot of really optimistic simulations that would assume these beautiful cubic curves in terms of how fans and pumps turn down. That's not reality. You got fixed pressures, efficiencies drop as you turn down. I think we're a lot better at that as an industry in Australia, if not globally, but historically it's been quite a challenge, as has the terminology around total pressure versus external static pressure, the difference being the losses that occur within the actual air handlers across coils and filters and things like that. I'm not sure if that's a challenge in the UK, but it's certainly been one in Australia. And I know that it's probably you're a little bit mature on specific fan and pump power in the UK, but just being mindful about the electricity in and not just the shaft to air, shaft to water efficiency, just making sure you got a whole specific fan and pump power allowance. I mentioned sump heaters, they also occur in chillers and heat pumps. And real buildings have real challenges with sensor calibration and drift. We don't put great instrumentation into buildings. The stuff we put in buildings is the stuff that process control wouldn't put in their processes, but we put it into buildings and it does drift and it goes out of calibration, and we need to maintain those things to maintain high performance. High flow, low delta T, so pumping systems very rarely pump at the design range. They'll quite often be at a portion of that, and that can really impact your pump energy use, if not your plant efficiencies as you bring on more units to satisfy flow as opposed to the actual thermal load. And then the last 3 points are a little bit of a collection of what can happen with something like an air-cooled chiller, let's say, where there's manufacturers' tolerances that you need to be aware of, and they can add up. They can be more than 10%, and the manufacturer is allowed to supply you that equipment with that less than nominal efficiency and still be within spec and within standards. So you just need to be a little bit careful of that. With heat pumps and air-cooled chillers, you will get recirculation onto those, and that will bias the temperature onto them, which affects the efficiency. And then you look at where that equipment's placed on the roof. It may be biased by warming from the roof itself, warming from the microclimate or the urban heat island effects around the building. And this is particularly, We've seen it on shopping centers where you got quite large roofs and you can get a 3, 4, 5 degree bias on your condensers relative to a weather file. So it becomes pretty substantial. So not all these factors need to be picked up within a simulation, but it's important to think consciously about them. And many of them should be in the simulation, and some of them should inform the level of margin that's applied to the simulation or the estimation. Next slide, Brioni. So metering and monitoring. I'm gonna have to speed up here, sorry. So you can't manage what you don't measure. You can have a neighbor's target, but it's really important to get it down to an end use level because quite often you have overs and unders. So we need to design these systems to be resilient so they self-check, have child meters that add up, that you can compare to the parent meter so that the system can self-diagnose itself, because guaranteed you will have a problem. And think about how you want to verify performance and design your metering system around that. Where you have heating and cooling systems, think about thermometers. In Australia, we tend to procure these systems with a single point of responsibility where the metering contractor will free issue the meters to the subcontractors to install, and they'll come back and coordinate the commissioning process. Trust is earned with these systems. I've never seen one work from day one, so you need to validate them. It's not that you're not trusting the contractor, but just you need to look at the data. Don't trust the data day one. Really check it with those checksums where you're comparing the parent meters to the sub meters. And if you get this right, your as-built targets become an energy signature, which can start to be used to, let's say, alarm against meters and that. Next slide, Brioni. So we're gonna have to speed up a little bit, but it was mentioned that tenants are half the solution with buildings. They're why we have buildings, because we put people in them. So don't lose sight of whole building outcomes. Don't take an approach where you are hell-bent on achieving the best base building performance to the detriment of the tenants. But set up a relationship where you have some control through house rules and fit out guidelines, and try and articulate acceptable ways that a tenant can use the system. This is probably more an issue in Australia than the UK with the types of systems that we typically use. But you really want to understand how the tenant's going to occupy and how they're going to connect, and is that a sensible way to operate the whole building? And it might be. And sometimes that might mean you take a little bit of a hit on the base building energy use in the spirit of achieving whole building efficient outcomes. Next slide, Brioni. So from a procurement and commissioning point of view, think about energy efficiency as an extension of the quality process. It's a performance criteria that does get specified. Make sure it's being reviewed through the shop drawing approval process. When you're dealing with bigger equipment, bigger plant, you have nominal efficiency, but also think about efficiency where the equipment will actually operate, and try and specify around that, because that may not be the highest design point efficiency, but it'll be the best efficiency where the building is likely to operate. Test equipment where there's uncertainty and risk exists. This could range from active chill beam turn down testing to chiller testing, and involve the energy consultant to review key performance criteria. So particularly around mechanical, the mechanical consultant should take a lead, but they should just be sharing what they're seeing from an efficiency point of view with the energy consultant, and they should be given an opportunity to tick off on that as well. Try and incentivize high efficiency versus compliance selections, get the best available fan and pump selections you can. And a really important thing, and I don't know what the state is in the UK industry, but the controls functional description is just so important. And for the collective team to think about what are they likely going to want to tune with, what are the levers they're going to want to pull, and making sure those are specified as being adjustable in the FD. So you have the ability to tune without having to reprogram the whole building. And if you get this all right, we haven't found that we've had to recommission buildings whole scale. We've typically found it does come down to controls tuning, but there are some cases where you do have to come back and reconfirm minimum maximum pressures for minimum volume and maximum volume. That's typically where there's been a series of fit outs that have been disruptive to the base building commissioning. Final slide, Brioni. So just with tuning and aftercare, I mean, you guys have a really strong base to start from the work that Adrian Lehman and Roderick Bunn have done over the years through soft landings. It's a great framework, embrace it. We're trying to, in Australia, still focus on collaborative relationships through that process to encourage transparency. Make sure the subcontractors, the builder, and the consultants have identified scope and budgets for that aftercare tuning phase, so that it's treated with a level of importance. Leadership in the tuning process should come from above. So it's not that the owner and developer needs to know everything, but they should be there, broadly aware of the process they want to follow and making sure the steps are taken. If they don't and it's left to the builder, they have an incomplete understanding possibly of what's required. And it's always good just to have a little bit of oversight, obviously, on that to ensure an honest process. Quite often we found that the energy consultant has been the sole person speaking at tuning meetings. That's really important that they're there to inform, but not lead the tuning process. So getting it down to how the mechanical consultant and other consultants understand what they need to do to confirm that things are as per design intent, and then the energy consultant can verify that and also inform where things should be targeted, where those consultants and subcontractors might want to look to optimize performance. Bring the facilities team in early, give them that opportunity and for them to learn and assist. And that facilities team must not act adversarial. They must embrace this as a learning process and an honest, transparent process. And the final thing is, quite often we find there's a lot of changes made in set points and controls through the tuning process. And it's important that the base building design team governs that, and that it's also locked away into a permanent memory of the control system, and then it's not a modification of the first image of the control system. We've quite often lost set point changes and controls changes. So it's really important that's tightly governed. It's also important that the building managers don't go changing set points in that without some governance around it by the base building contractor and consultant team. I've gone over time a little bit, I apologize, but I think that's the end of what I have to say for now. Thank you.
Thank you, Graham. That was an excellent tour de force of your experiences, and obviously some great learning points there for everybody, and a real practical perspective of how you deliver Neighbours in practice on the ground. And I'm sure that Graham's probably delivered a number of buildings to our next speaker, who's going to give us a client's perspective of having buildings in their portfolio that are Neighbours rated, maintaining that and working closely with their occupiers to ensure that the best outcomes are achieved. And it'll be interesting, I think, for a number of people on this call. I suspect there's a number of property company representatives who want to really understand what this means for them, and I'm sure we're going to hear about that from David. So David is from a company called Mirvac. Mirvac are one of Australia's leading property companies. They have a diversified portfolio with something in the order of 24 billion Australian dollars. Don't ask me how much that is in UK pounds, but I'm sure if you need to know, David can tell you. David himself is a sustainability manager for Mirvac's commercial portfolio, and he leads a team of highly skilled in-house sustainability professionals. The team's responsible for the delivery of Mirvac. This changes everything, sustainable strategy across the office, industrial, retail, and build-to-rent portfolios that they manage. So I think over to you, David. We'll get that perspective. Interesting, as obviously if I come from a client background myself, so I really want to hear how it goes once you get these buildings.
Thanks, Neil. Thank you for the intro. Apologies to everybody, and good morning, everybody. Apologies if some of this sounds like I'm stating the bleeding obvious. And I'm sure if I was on Mastermind, which I'm not smart enough to be, it would be, my specialist subject would be stating the bleeding obvious. But a lot of it really is common sense, and that's what we've learned, and we've learned, unfortunately, the hard way in a number of these elements. So we just really wanted today to take you through what we've learned along that process. The first slide, if we can just pop to the first slide, please. the first slide I just wanted to bring up, and this is partly a shameless plug for our sustainability strategy. This changes everything. But also, I just wanted to mention one piece there around that Neil mentioned. We've been in business since 1972. We've got a reasonably sized portfolio. One of the things that's really quite different and maybe a little bit unique about Mirvac is that we're a developer. We construct, we manage, and we own buildings. And it gives us a unique feedback loop. We feel it gives us a unique opportunity to look at whole of life, or to certainly take a long-term view. And that's where we've really found the value of metering verification. The NABERS process has really given us a tool to use in that piece. So if you could maybe pop to the next slide, please. And what we really wanted to do with this one is just maybe talk about the evolution of NABERS in the Australian context. Just before we get into how we use it in terms of monitoring and verification, we've seen some real changes over the 20 years that NABERS has been going in Australia. We've seen some huge changes. One thing that we really like about NABERS, and one thing we really like about what we call the commitment agreement, or the design for performance element, is that it's a clear statement of expectations. It's easy. It can be used by local government authorities when we're looking at development requirements. So it's often built in the sustainability requirements for new development, or the conditions of consent on those applications are often worded in NABERS requirements. So it might be a 5-star NABERS outcome. It's also used by tenants a great deal. And we've seen that through a number of years, starting with government departments in Australia, which required a minimum 4.5-star NABERS outcome for them to move into a building, which really started to change the market. So it was actually really tenant-led type requirements that started to move the market. But also now we're seeing that evolve, and we've had one recently where a tenant was asking for net zero operations, as well at the same time as asking for a 5.5-star NABERS energy commitment up front. So it's really good to see that. And so it really makes those communications quite simple. I think you'll find, if you look at all of the Australian real estate investment trusts, you'll find that NABERS forms a big part of that strategy. So it's the energy efficiency component of that strategy, and also how we report on that. Maybe it's through minimum requirements for portfolio ratings or individual building ratings. And finally, it's also used extensively by government, not just for mandatory disclosure, although that's part of it. So if we're leasing more than 1,000 square meters in Australia, we have to have a building energy efficiency certificate. Part of that is actually having a NABERS rating. So tenants can see what that NABERS rating is, and tenants equate that to the building efficiency and OPEX. There's also, the government has used it a number of different ways. You can use NABERS to generate energy efficiency certificates. You can use NABERS even in funding opportunities. And we've also seen it used for energy performance contracts, where it's really simplified that language around, we want to take the building from maybe a 3.5-star to a 5-star. So it's really helped with a number of those things. So if you could just move to the next slide, please. Thank you. In terms of how we use it, so really with this part of the presentation, I'm really going to focus on metering and verification. I work in the operational side of Mirvac's business. I do work with the development teams, but a lot of that is trying to pull that operational experiences and learnings back into the design process. So some of the learnings that we've had about really how we integrate NABERS into the process, it's really been a key part of, and it's been a key enabler. It's made that whole M&V process way more effective for us. We find that actually having a model up front and then being able to track performance against the model through an operational rating tool like NABERS has just made the whole M&V process far more effective. We found that some of the big learnings we found is we really need to understand the modeling assumptions up front. And some of the big three that we've really found helpful is understanding what the model assumed in terms of the tenant usage, the occupancy, and out of hours usage. We've also found that we can use some of the designer tools, the off-axis modeling that forms part of the NABERS process. We've often found that we have problems with tenant condenser, water loop energy, vertical transport, and often after hours AC usage is much higher than we originally thought. So we can play with the off-axis modeling, and then we can get some value out of understanding how the building might operate under different conditions, just so we can get our heads around what to expect. And then also, I think a couple of the speakers, I think Peter and Jen, and also Graham also mentioned about that early operational input. It really is critical. We can learn from our mistakes and start to bring them into the process. And finally, just for this one, in terms of that initial elements that we've really seen a disciplined document management system has really been a key element for us. I'm not just talking about O&M manuals here, but things like neighbours modelling results, the modelling assumptions, expected exclusions, the metering trees, you know, all the stuff that often goes on a thumb drive and then gets lost down the back of the sofa. Having that in a document management system will pay dividends later. It's often those are the things we've been scrabbling around for when we're really trying to understand performance. And moving on to the next one, just again, if we can just, thank you. Metering, unashamed apology for this, but we've learned the hard way just how important metering is, and we've certainly found that metering, if it's not the most critical element, it's a hugely critical element to getting this right. One of the first things that we found was making sure that everybody in the team really understood the neighbours metering requirements and what meters there for. We've had some bad experiences with members of the team who were quite critical components to the team not really understanding some of the elements about, say, exclusions on the neighbours, which has caused a few issues down the track. We've also learned the power of a simple meter map. The one we've used here, it's a really simple example, but even simple things like this, it can identify where we've got meters in the wrong place. As you can see, we've got a meter on the power factor correction. We picked that up because we had a simple meter map, got lost on the single line diagrams, but simple meter maps make a huge difference. One of the most important things, though, that we found, and again, we'll learn from experience from the UK as well, but one of the things we found, we really need to reproduce the energy model. So if the energy model is 5, 10 different components, we really need the metering to be able to fully reproduce that. And again, it sounds like the absolute bleeding obvious, but it wasn't until probably 5 years ago with this particular building that I'm in now that we actually, first time that I've worked on a building where we actually did that. And it made a huge difference. And I think hopefully I'll be able to show that in the next few slides, just how important that was. Another area that we actually learned the hard way was virtual meters. These cause all kinds of problems, and it often compensates for issues. So we find that we just don't use them anymore. We much prefer to spend a few extra dollars and put a meter in rather than have the worry that the virtual meter is just compensating for problems elsewhere. And also then meter validation. It's a really big point. Making sure we've got meters in the right place, making sure that exclusions are picked up. Exclusions are often a big part of neighbours ratings, making sure that you can exclude maybe retail at the bottom of the building, or maybe parts of the car park, for instance, that might be public car parking. That can be a huge anchor on a rating if you don't get that right. So making sure that you've got the meters in the right place, you've picked up your exclusions, and then they're validated. So not only just validating the meters, which is an important element of that, but also that you can actually get to them, you can read them. We've had several meters that get bricked up after the event for some unknown reason, and we've had to go back and find a way of reading those meters. And if all this comes together, what we can find is that we can actually do a reconciliation of the meters, so we can look at the child, how they add up to the parents, and we've got this within less than 5%. So we do feel that we're on the right track in terms of what we can do and what we can find with the metering system. If we could pop to the next slide, please. Just a quick example here of the power of that. So this is again 200 George, based here in Sydney. It's about 40,000 square meters, so 400,000 square feet, I think that is, if my conversions are right. What we did here is we modeled the building at 5 stars plus 40%, and we actually achieved a 5-star plus 27, so that's just above a 5.5-star neighbours energy rating. This isn't particularly sophisticated. I think we got better, but what we tried to do here is, again, we looked at the energy model and then we looked at the actual performance and just saw what the difference was. Now, there's some complete stuff ups here. The miscellaneous ventilation got lumped into the light and power accidentally, so that was a bit of an issue. The lifts, neighbours use, in Australia, neighbours uses an assumed 8 kilowatt hours per metre squared per annum for lifts. We've found through this process that high-rise buildings are probably running that somewhere between around 10, maybe even 12 for a premium building, and they might be running at around 5 for a more of a low-rise. So it's certainly things to take into account with the modelling. We've also found, again, the pumps often are quite a difficult area because we do struggle around modelling, good modelling with container condenser water and other issues. But again, it just means that we can actually track this into performance. We can work as a team and try and tune the building. So if we can move to the next slide, please. It's just a little bit more sophisticated now. So if you follow cricket, especially the IPL, you'll be comfortable with the worm kind of concept. So what we've got here is we've modeled different areas. And I should say this is actually an ARUP report on one of our new buildings. This is Australian Technology Park. So we engaged ARUP for 24 months post-PC to produce reports, but also help us with the tuning process. So what we've done, or what Arup have done here, is they've looked at the top line, which is, I think that's orange. That's a 5-star outcome. The next one down is 5.5-star neighbours outcome. Next one down, one of the blue lines is 6-star, and then the actual model. And the green line is actual performance. So you can see that we were a little bit under 6-star, lower occupancy in the building to start with, kind of moved up a little bit, and that's probably more through gas, through dehumidification, and also summer loads. But it means that we can just actually see where we think we are at any point in time against what the model's saying. And I think the next couple of slides, if we could move on to the next couple of slides, please. Just in a bit more detail with these ones, we're actually now looking at actual subsystems within the building. So again, this is where that metering breakdown makes a huge difference. And I thought really we should show the good, the bad, and the ugly. So maybe not quite the ugly, but certainly the bad. The gas consumption, we were a bit over where we wanted to be, and we were certainly looking, we've modeled this building at about 5+, I think it's about 5+50, 5+40. And we were certainly over that, but certainly still in a good 5.5-star range at first. We managed to get the boilers down quite significantly, and then we saw, because of dehumidification in the summer months, gas usage increasing above where we wanted it to be. So it's certainly a learning curve in terms of tuning the building, and especially around gas and dehumidification around chill beams. So there's been some good learnings there. The next one's the vertical transportation, and pretty much exactly what we're expecting. Neighbours was expecting, or the design used about 8 kilowatt-hours per metre squared per annum, when we're probably running about 4 or 5. So it kind of fell into what we were expecting. The next slide shows us a couple more systems. And again, it's just really helping us to tune the performance and really understanding and use the model to help us understand what we should expect. Probably to start with the ugly, the tenant condenser water, we always seem to have problems modeling tenant condenser water. So again, we do use the off-axis opportunities to have a look at what the building performs like if we've got 2, 3, 4 times more energy in that space. Not a huge amount of energy, but it's certainly something that we need to be aware of. And interestingly, it's often not because of temperature. It's more to do with flow or to do with pressure drops. So it's an interesting one for us in how we tune the building. The gas, domestic hot water, and for heating now, I think you can see we started off with a little bit of an issue, or sorry, this is just domestic hot water. Getting the meters right at first means then we can track it much more actively. And that's an area where we've actually tried to tune the building. But again, without the metering, there's no way that we could really start to pull things apart and also have a good opportunity to do that. So the next slide will show a couple more elements we find particularly effective in the M&V process. And those 2 elements are using daily profiles. This is a daily profile from a meter. This is only a small building, it's about 8,000 square meters, but it was part of an energy performance contract. We were struggling to achieve the performance that we wanted, that we paid for. So we just looked at simple things like the utility meter in the building, just looking at those daily profiles, making sure that we get a sharp turn on, sharp turn off. But really what we're looking at here is a base load condition. The base load condition was causing major concerns for us and was probably one of the biggest issues that would have impacted us in achieving the neighbours rating we wanted to do. So we often walk the building late at night just to see what kind of loads are operating. And with this particular one, we've been able to reduce the actual base load by half. Not always see quite as dramatic results as this. But if we could just jump to the next slide, just as what we're trying to show here is that base load is a big impactor on neighbours' performance. And it's something that we find that we can actually control quite well, and we can get those things down. So no surprises, the 2 best performing buildings on here, Sirius in Canberra and Bay Centre in Sydney. These are 2 6-star neighbours rated buildings purely through energy efficiency. So you can see the impact of base load in terms of getting to those really high performance ratings. It really is an anchor on performance where you've got these really high base loads. The next slide, if we could just pop to the next slide, please. Thank you. Just trying to pull together the M&V piece in that we really see this as a feedback loop. So what we've done is that we look at it from a development perspective, moving to construction, moving to operations. So build, measure, learn, and then we feed that back into the initial development. And we've actually built our own set of operational design guidelines. We're on to version 4 at the moment, and I'll promise that we didn't use cogen pictures on version 4. But it's really about how we capture those learnings that we're picking up through this tuning process and how we feed them back into development. And I think that's been picked up by a couple of the speakers before, just in terms of how important it is to have that feedback loop in place and to really start picking up on those operational learnings. The next couple of slides, if we could pop to those, please, just in terms of some of the challenges. And again, I don't think there'll be any surprises here. And I don't think there's any real answers, unfortunately, from what we're seeing, but just highlighting some of the issues that we've seen. Contracts are still quite challenging. I think Graham touched on how to manage those contracts. And I think the same as what Graham said, we prefer to work as an integrated team. And to be honest, Mirvac, we tend not to put contractual guarantees onto the designers. We feel that we're going to pay a premium in risk around doing that. But we've really found it quite difficult to say, well, are we paying for a system? Are we paying for performance? What falls under design versus what falls under construction? And then what falls under design versus what falls under operation? We've certainly had discussions with designers in the past around, some designers have actually said to us, well, it's all to do with operation. Well, kind of think the design has a bit to do with it as well, but it's finding that sweet spot between the two, and both of them really bring key skills to the table in how we do this and how we deliver. And really, just some pieces there to finish off really on this particular slide is that just be aware of value engineering late in the process, in the design process. You might save some money up front, but we often find that we pay for it as we move down, and we're lucky that we can take that long-term view. But one thing I probably should mention here is around system readiness. If those systems can be ready at PC, it makes a big difference. And that can be metering platforms, it could be analytics platforms, even some of the reporting elements under the building management system. Makes a big difference in terms of trying to achieve Neighbours performance if those systems are up and ready at PC. The next slide goes into a few more challenges, fairly obvious again, but I think FM workload is one that we should really bring up. We find that there's a huge workload early in the process when you're transferring buildings into operation. You know, an FM's part of that team. They're working hard on the defect liabilities. They've got tenant fit out works, and they're really a team leader across the team, whether it be internal or external partners. So there's a hell of a workload on. And again, we find that having an FM on board maybe 6 months before PC is a good compromise, and actually gives us opportunities for the FM to really learn the building before we really get into operations. But they really need support as well. And I think maybe just to finish this one off is just to say, just be aware that we don't see many FMs get through a full 2 years. And they're often, the workload is just so much that you often find that FMs will move on in that period of time, and you do lose a lot of knowledge if they do move during that time period. If you could move to the next slide, just a couple more to finish off. I think Graham mentioned just the importance of soft landings, and I'd just love to support that view. We're a huge fan of the soft landings process. We think it provides a huge opportunity for the owner to really get involved, or ourselves as the owner's representative. A couple of other things that soft landings that we find it gives us is a process, a framework around which we can work. So it gives us the platform where we can report back on the monitoring, we can review. It might be another platform where we can look at things like the ARAP report, where we looked at actual performance. It's a great opportunity to integrate the team, but we really need to make time for it. And the earlier that we can put time and effort into that, we often find that's the critical process. The critical part of the process is that first 6 months. So really getting the building under wraps in the first 6 months before it gets away, and then becomes quite a difficult operational challenge. And finally, just wanted to finish off on a slide that shows just how this fits into a historical context. This is actually a slide from a report. It was the Low Energy High-Rise Building Research Study. It was released in March 2009. It's from the Warren Centre for Advanced Engineering as part of the University of Sydney. I don't want to bore you with all these points, but we felt that this really demonstrated the importance of having really engaged, curious people, especially in the FM role, to actually drive this process, and just the difference that those people can make. And just a couple of things from here, in that it found that having an engaged FM, it often talks about in-source and outsource. It really comes down, if you've got an engaged FM, they can have a 1-star difference in terms of Neighbours performance. And just where the building management team have a higher knowledge of energy efficiency, again, up to a 1-star difference. So those people can make a huge difference to what the outcome is. Again, no real surprises there, but people do really make a difference to this process. And on that note, I'll hand back to Neil.
Great, thank you. Excellent presentation. I think we're going to now move to the panel session where there'll be an opportunity for you to ask questions, and I'll put them to the panel members. So all the speakers that you've heard so far are going to be on the panel, but special mention, we're going to be joined by Carl Brooks. Now, Carl is from CBRE. He's worked in the sustainability sector for 20 years, and the last 13 years working in commercial real estate. He's currently a director at CBRE UK, where he leads the development and integration of sustainability as a core competence and service within the property management division. I think we just heard there from David how important the FM role is. So I'm going to ask Carl to give us a couple of minutes of his perspective, and I hope he's going to tell us that he's got lots of engaged and curious people in his team, because it looks like there's a significant increase in the workload coming your way. So over to you, Carl.
Finally, yeah. Thanks, Neil. No, and really, really good to hear from all the panelists today. I think it's kind of it's always good to go last because you can kind of benefit from what everyone else has said. And the kind of drawback is there's a bit more of a time pressure. I think from my perspective, talking at it from an operational setting, we've always kind of looked at the art of the possible with kind of new builds, but the kind of reality that we are facing, depending on which kind of study you read, is that 70% of all the buildings that are standing today will be here in 2050, and half of those were constructed prior to 1970. So the existing stock, which is going to have a huge impact on how we can achieve our decarbonisation sort of targets. A lot of them were around before we even started to think about energy efficiency as part of the design process. We've been reminded this morning by Chris that there's obviously a huge difference between the assessed design intent of a building and the performance and operation performance gap that he mentioned earlier. That shows no correlation between those two indicators, which kind of causes an additional sort of challenge to us when we are assessing buildings based on the statutory document around the EPC, and then having to assess how the building is actually kind of performing in operation. So while the kind of design for performance aspect of what we've been discussing today is clearly an important sort of program to ensure there's accountability during design and development for how a building performs in operation, it's kind of really important that we do involve the operational teams as an earlier stage as possible, as kind of several of the speakers have kind of mentioned this morning. It's much kind of better to kind of do that than to try and like adopt a building and then reverse engineer solutions once the buildings are in operation. So I mean, the good thing is that with the kind of increased focus around this area, there's going to be like an acceleration in the innovations around this space, kind of and a lot of those innovations will be applicable to existing assets. But really, the kind of key thing for us as property managers is to be able to assess a building using a kind of benchmark, in order to use that as a springboard to assess what's the necessary reduction that either delays the stranding risk of an asset as far as possible, or achieve net zero carbon, or both. What we can then look at as being possible now to achieve each asset. There's no silver bullet, as Jennifer mentioned. Every asset will be different. And finally, what's practical within the constraints of the building itself, the ambition of the asset owner, and the appetite of the occupier. So your Neighbours energy rating is kind of clearly of prime importance to us as property managers, and to us as a kind of sector more broadly in enabling aspects of the above. But all of this needs to be supported by changes in the day-to-day operations at the building level to ensure that those ratings improve over time in line with the carbon reduction objectives. So as has been mentioned, these changes may involve a review of the FM service delivery, changes in the maintenance strategies that we adopt, so maybe moving from planned preventative maintenance to condition-based maintenance, possibly facilitated by the kind of greater shift towards smarter, intelligent buildings, where technology will play a greater role in all aspects of property operation, and potentially even enabling self-regulating buildings that ensure operation within agreed parameters, almost negating the need for that human intervention. But there's obviously a lot of unknowns there around the dependencies between such parameters and how that might affect energy over time. And then it was mentioned as well earlier, but the final part of the puzzle, and one that's kind of really kind of key for us, is one I think that Graham mentioned in his presentation, David picked up on as well, is around how we acknowledge the contribution the occupiers make into the performance of the building overall. the common pitfalls that were mentioned around small, like the use of small power, unplanned or unmodelled out of hours use, and indeed the effect that occupancy has on building performance, depending on how that affects how systems kind of work in operation. So, I think David, like you mentioned there, around how Australia has adopted, kind of requirements in tenant leases, around energy performance, and that for me is probably a logical progression in the UK. So, yeah, the to-do list in operations is ever growing.
Okay, thanks for that, Carl. So I think starting with a question, I think for Peter, I think you're involved obviously in implementing design for performance as one of the pioneer group for the Better Building Partnership. So it made you confident that it will enable owners to deliver a better, more efficient building? And what have been the benefits that you've immediately had from the initial modelling stages that you've gone through? And I know you gave us a bit of a health warning in your talk as well. Perhaps you want to return to that.
Yeah, Dave's grinning at me there. I think it's a kind of rallying point for us, really, that we're all focusing on the same objective rather than what tends to happen with appointments of designers, appointment of contractors, appointments of FM, and so on, is that it's all fragmented. There's a kind of a baton passing process that goes on if you're lucky, and it gets dropped somewhere, rather than it being a scrum where we all take the ball across the line. So in that respect, it's been quite uplifting, really, to see people focusing on that same outcome. But where we're at the moment with our developments, I guess most others, excuse me, is it's all about potential. So the model and the DFP process is really about delivering potential that's then going to be ultimately realised and measured in the Neighbours rating when the building's in use. So for us, our focus is we have lots of discussion about the model, and it's a very nice thing to talk about. We all have a good drop-down box, don't we? But it's all the things that go beyond that, like how we appoint our consultants, how we engage our consultants with our contractors, and that varies with contractual route, of course. And then there's all the things that you could just read on a programme, on a timeline, through procurement. So we've been able to have very good conversations about controlling the extent of competition that might go into procurement for equipment, for instance. If equipment's been selected to achieve a performance in the model, then that's really important. And simply then allowing equipment to be selected by somebody's procurement department is a recipe for disaster. So we've worked our way through these things in quite an amicable way so far, because again, we're not arguing with one another about the particular discussion point. We're always talking about how do the things we're doing now ultimately lead to both the right target and the right certified rating at the end of it. We've generated a massive to-do list, I think is the truth of it, and these presentations from Dave and Graham have just added considerably to it. Of all the things that we've got to deal with, and that all of us who are in the Pioneer projects are kind of, at least to a degree, making up as we go along. So areas that are still large on our radar are about early enough appointment of a building manager of an FM. I think that's going to remain a problem because, Carl, you probably like to say something about that. That's not our usual model to procuring FM. FM is procured at the last possible moment, often irresponsible moment, on the lowest tender basis. And there's a lot of churn. The continuity of FM providers and individuals, once we've got them in the first place, is a real problem because of the loss of knowledge. Beyond that, there's so what do we put in a contract for an FM provider? How do we work with them to make sure that they understand what they're supposed to do and how to do it? How do we make sure their staff remain engaged and have the continuity we talked about? And then beyond that, there's what do we do by way of leases or memorandum of understanding with occupiers to get them engaged in project in the process as well. And I guess at the moment, a lot of the focus is as I say, it's an end goal, which is let's get to good neighbours rating. But in truth, and Dave's presentation showed this, that's just the getting out of the blocks, isn't it? Beyond that, we want to make sure that the rating is at the very least maintained, but ideally we learn from the process and continue to improve it. So loads and loads of potential, very excited by it all, Neil, but awful lot of things to do and an awful lot of solutions to be found for problems we're just discovering.
I think you gave me enough questions there for about 3 Q&A sessions. So, and you're one of the panelists, but I understand. I mean, we're obviously running the Neighbours UK and Design for Performance across a number of our new developments. So I understand those learnings we're all going through. So I was just thinking, Jen, from your perspective, obviously there's a lot of principles here for people to understand within the market. We need to get that learning down right through the supply chain, from the designers at the beginning of the process, right the way through all the delivery and construction of buildings, and then obviously on into its operation. You know, what do you think are the ways that we're going to enable that to happen, and what do you think we need to do? What's the priorities?
Yeah, I mean, I think sort of echoing what everyone on the panel has said so far is really there are no silver bullets, and to say it again, and there's going to be learnings as we go along. So I think step one is to get started, honestly. Beyond that, it's really then about making sure that we can have those continuity of appointments, and making sure that as, for example, a designer, you do see the building in operation, you can do that monitoring and verification piece on your own building. And often the way we procure design contracts is structured in a certain way that prevents that. So I think the first question from our perspective is really, how can we structure those appointments such that the continuity is there and the learnings are maintained both within that design team, and then obviously the next step, building on the independent design review panel and the design for performance pioneers, is how do we as a community share those lessons between ourselves?
Interesting, and there's a lot of learning to do and education, I think, within the whole sector to get everybody joined up on this, because I think, as everybody said, it's a collaborative effort to make this happen. I've got an interesting question here that I'm going to put to both David and Graham to see if you can give us some perspective on this. But a question around how much capital clients would have to commit to achieve, say, Neighbours 5 or even a 6-star rating. And what sort of analysis has been done on the value outcomes? You've obviously got a lot of experience in Australia of taking buildings through the process. You know, we're always trying to do more with less, and it seems we all need to spend a lot more money on meters, and there's some interesting detailed questions on that I can throw at you if we have time. But I think it would be interesting to sort of understand, you know, what sort of premium has had to be invested in the buildings to enable the levels of performance to hit those higher ratings has been.
Do you want me to answer first, Dave, or?
Yeah, please, Graham. I'll pop in on the operations side.
Look, I think it's a tricky one, and I think you need to look at our market conditions when Neighbours was released. So it was released at a point in time in the late 90s where Australia was well and truly coming out of a mid-90s recession, and we were booming until 2007 when the GFC hit all of us. And even then, Australia plowed through the GFC. The office market in Australia has been very tenant-led. And as tenants wanted, you know, to be more corporate and socially responsible, they were specifying their accommodation requirements in Neighbours terms, and then eventually Green Star terms as well. So as a developer of new accommodation, or existing for that matter, you had to, you know, be there to have the ticket to play. And so the capital premium wasn't necessarily questioned. However, we're probably at a point where we're kind of adopting best available technology almost to the point of saturation now. And so the incremental improvement that I think we'll see, we need to be a little bit careful that we don't start automatically pushing to 6 stars on, let's say, a high-rise Melbourne office building, because it's not really possible to be done in a capital efficient fashion. So I think some of those questions, I don't want to dismiss the question, but we're having to answer those now rather than over the last 15 years, because it just hasn't been challenged because of market conditions. It's just been, what does the tenant want? And they're willing to pay the rent. And we've just done what's needed.
Okay, well, I don't know if you've got any thoughts on that, David. Obviously, the UK market's a bit different to Australia in that we don't have so much pre-let activity in the UK market. There's a lot more spec building. So obviously developers and investors have got to invest in those buildings up front before you really understand the full requirements of an occupier.
I think we can talk to that, and maybe we can change the conversation a little bit into a value rather than a cost. And as Graham said, if you haven't got good neighbours performance in a new building, at least 5-star. And I think 5-star, I don't think you'd have to do an awful lot. You just have to do good engineering to get to 5. If you want to get to 5.5 and 6, yeah, you've got to do some a bit more special, and you're going to pay a bit more for that. But if you just look at that 5-star, you're not going to get premium tenants without it, and you're not going to have your building leased in a reasonably quick manner. So some of the benefits or the value that we see with high neighbours performance or highly sustainable buildings, your building will lease up earlier, you'll have less downtime, you'll be able to get good quality tenants. Example here at 200 George Street, we were pushing for a 5.5-star. We got to the 5.5. As many times in the design process, we thought we'd only get to a 5-star outcome. By pushing up to that 5.5, we saved about $200,000 a year in energy costs, which, if you look at that from a cap rate perspective, it's about a valuation uplift of about $4 million. So there's certainly a valuation benefit. We're also seeing in Australia, there's some research by the IPD and also MSCI, I think it is, which says that buildings with high neighbours ratings and also high Green Star ratings here in Australia, they outperform the market by about 10 basis points in terms of return on investment. So we're certainly seeing that in terms of a value equation. And like I said, I don't think a 5-star building is going to cost you any more. And without it, you probably won't get development consent, and you're not going to get the best quality tenants either.
I actually had a related question, Neil, if you don't mind jumping
Go
in
ahead,
for
yeah.
Graham and David on that point. Is that certainly a challenge we have in the UK is that we know we over-specify in terms of the size of plant in our designs, and kind of theoretically going through this design for performance approach, doing better modelling and having confidence in that model, we should be able to specify plant more accurately in terms of what is needed in terms of that operational performance, and therefore reducing capex costs. I was just wondering, do you have experience of that and evidence of that in Australia? Are you, well, one, typically historically, have you been over specifying plant, but are you able to more correctly specify plant sizing and so on as a result of going through the neighbours commitment agreement process?
Absolutely. I think Graham's probably best placed to answer that particular one. If I could maybe just with 200 George, our experience when we got involved from an operational perspective on 200 George, we had cogen and all kinds of stuff in the building. We actually came along and said, no, get rid of the cogen, get rid of a lot of exotic systems that we didn't want. Just give us a few extra meters so that we can reproduce the energy model. And that will give us what we need to tune the building, because we actually did have some really high quality, the facade and some other elements. But we were actually found that we were de-speccing in many spaces. Graham, is that your experience?
Yeah, I certainly agree when we talk about on-site generation and that. We should stick to our core business in buildings, which isn't generally running sewage treatment plants or power plants. And I think just to extend what David's saying, we spent a lot of time in our industry kind of looking at, let's say, tenant VA a square meter on floor, or the light and power heat loading allowances, and how those might diversify at a building level. And we've pushed that to a level that we're comfortable with, and I guess changed the market over 10, 15 years in that regard. So that there's not too much over specification. Now, what that's then allowed us to do is to take some of the capital that would be in stranded infrastructure that's not used and actually put it into efficiency where you're going to get a benefit from it. So it's been a bit of a swap that as a design and construct provider, we've, I guess, played that game to optimize performance with a lower capital cost. Interestingly, if you over-specify systems, if they're larger capacity, and they have the ability to turn down, it might actually be a more efficient outcome. But you need to look at all load conditions, because if you've got a big air handling system and bigger risers, it's ultimately going to be at a lower pressure once you turn it down. But the key is the systems need to be able to turn down to the real operating points, which surprisingly might be a lot lower than what we all think, particularly with COVID type operation. So.
Yeah.
I'm not promoting oversizing, but it's not necessarily a detriment.
Yeah. No, the engineering physics behind that is known, I think, and in terms of performance, particularly with chiller plant and the like, with condenser areas and stuff. Just moving on to Carl. We've heard about costs from investing in the building in the first place and putting the money in the right places. Do you envisage this is going to drive some premium into the FM world in terms of being able to stay on top of all the different work streams that have been described, or do you think that's something that you already do and this just is going to focus it better?
I think there has to be a rebalancing of the services being delivered by the FM teams. I think over a number of years, I think the kind of FM provision has been sort of in some ways kind of de-skilled in certain areas. And I think with the kind of rise in increased kind of building technology and the need to better understand some engineering principles within buildings, there is a requirement to improve delivery around FM and M&E services within the kind of built environment. So yes, I mean, I would say clearly we would be looking at upskilling the industry or employing a sort of maybe a slightly different team within certain assets to be able to deliver these quite specialist services, which can then help ensure that the buildings are operated at their most optimum level. So I think it's inevitable that as we go through that process and those roles become more specialist again, then there would be a premium attached to the delivery of that service. I think it might also be linked in kind of contracts with M&E providers or providers of kind of teams who work on specific plant and equipment within a building. So there's like a risk and reward attached in operations around kind of good performance or kind of poor performance against that design standard. So there may be some kind of clawback there, but I think the kind of overall aim is to improve performance at the asset, and if that needs a better caliber of engineer working on the site, then that's what we need to be looking at bringing in.
Okay, we've only got a few minutes left, and just trying to look for a question that maybe incorporates a lot of the things that we talked about today that I could throw at you quickly, and you'll give me a sort of your particular perspective as quickly as possible, please. But obviously, we've heard a lot about the importance of collaboration and the modelling and effective meeting design. But how do we ensure that the UK construction industry, which isn't known for its collaboration, actually do come together to work effectively and efficiently, avoiding duplication of modelling, ensuring that the information passes from hand to hand, and we get the effective metering that has been mentioned many times, both in terms of its delivery, and that goes across, you know, electrical metering is usually reasonably good, but in my experience, certainly, you know, the metering for heat energy and cool energy and even water metering sometimes can go awry. So, you know, any quick thoughts on how we start to make that happen in the UK, either from the Australian perspective or from the knowledge from the UK-based panelists?
I'll go, Neil, if you like. I don't have a universal answer for this, but I think we've got to make it highly visible and obvious. Not exactly name and shame, as it were, but we ought to be able to see how buildings are performing. Public ought to be able to see how they're performing, and the occupiers ought to be able to see how they're performing. And if it's visible, then there's a very, you know, prominent feedback about whether we're doing what we said we would do. That's a difficult thing to organise sort of through construction commissioning and the rest of it. But I think the principle remains the same. We've got to make it really visible that people have done what they said they would do.
Great. Anybody else got anything else they want to add to that, or?
Maybe Neil, I'd just like to add that we found soft landings to be particularly helpful in that process, and having key designers at the table, key contractors at the table, ourselves as the owner's representative. I think we found that's been most valuable, and it's got quite robust in terms of how the building's operating versus the models. But it's an opportunity for us to learn about the modelling process, and it's an opportunity for the designers to learn about the operational process. And I think putting those two together makes a big difference.
I think you mentioned earlier as well about the value that is seen. I think we can all see the value that there will be in terms of reducing carbon emissions and was really starting to tackle the climate emergency that we have at hand. And you know, the built environment's a key player in making that happen. But I think from a sort of other value perspective, I think you mentioned that, you know, funders and investors in Australia have really understood this and have given that support. Is there anything, you know, you'd like to sort of say from a conversation perspective, how this UK industry can engage that same audience?
I think one thing, Neil, would be to say, think about it from a value perspective rather than cost. And cost is up front, and I recognise it's always front of mind. But if you get into the value, I think you'll find that will hugely outweigh the costs. Like I say, 200 George, $200,000 a year saving in energy, which we can directly pass back to our tenants. So we've got an OPEX perspective, from a better perspective, but then also the valuation uplift. But then also Neighbours is actually, we can use the Neighbours tool to generate energy efficiency certificates. So it's not a huge element, but certainly that's good. And then we can use it also to go to investors and say, well, look, the benefits of this portfolio is that it's low carbon, and often we can demonstrate that through a Neighbours rating. So it helps with communicating that to investors, in that we're a lower climate risk because we have a high quality portfolio. Directly comes back to the Neighbours performance of the portfolio.
Okay, I think obviously today the BCO has been hosting this webinar, and it's been great, the work that's been done by Better Building Partnership and hearing about that Australian experience. I think the BCO is very keen to support best practice in all aspects, as I said at the beginning of the presentation. And we need to really start to think through how we're going to support that. And I know Peter's obviously a member of the Technical Affairs Committee, so I'll perhaps throw this to him, but also perhaps get Jen last perspective from you on what we can start to do to help socialise the knowledge, try and raise the game of the industry and to take us forward.
Yeah, absolutely. And I think, you know, the BCO guide to specification is an enormous benchmark in the industry. And certainly, you know, we saw in Australia having the Property Council of Australia, which is sort of an equivalent, embedding Neighbours ratings within the specification process was a really key first step. But then I think beyond that, these kind of webinars, these kind of events, and the ability to, I think, share knowledge across roles and across the industry is so powerful. Just being able to hear the perspective of the person on the other side of the phone is just really valuable in sharing, collaborating, and socialising that knowledge.
Great. And Peter, I think we've got a bit of work to do to try and capture some of these learnings and play them back through links to the guide and the other technical publications that we do as Technical Affairs Committee. Any thoughts where we're going to get the time to do all that?
I don't know. Invent another day or something. But I think you're absolutely right. It's about feedback, case studies that make all of the learning we've got here accessible to the membership. The collection and collation of data is going to be vital. We'll be going back building by building, and individual designers will see that data on their building. I think where there's a bigger role to play is collating all that information across all the buildings or seeking Neighbours ratings to give a broader level of feedback. And I guess that's something that we're going to have to engage with BRE on, a scheme administrator, to make sure that that information is in a good format and available to all who could benefit from it.
Yeah, that's great. I think
I'd like
that
to
also
say that,
go on.
back to one of my first points, I mean, we don't know everything and we still find it tough in Australia. And so while we've dumped a lot of things, they remain challenges. We don't have all the answers for all of our challenges. We're still working on them. And so just be a little bit realistic around, you know, tackle the big priorities, recognize it's a bit of a journey. Things will evolve. There's probably stuff that can be codified, you know, eventually in that, and learn from Australia in that regard. But you're not going to get it all right the first time around. We are still learning through this process.
Okay, well, I think just as a sort of final couple of thoughts from myself, I think what's next for the BCO, well, certainly I think we should think about an event focused on the Neighbours rating on existing buildings. We talked a lot today about the modelling process, the design of buildings. Meter seems, you know, that you have to do a 3-word alliteration of the same word these days, but it certainly seems that metering is key to making this happen. But we obviously, if we're going to tackle the carbon emissions in the property, we're going to have to deal with the existing buildings that we have. Some of those buildings do have good metering systems, many don't, so there's obviously going to be some investment there. But I think certainly it'd be worth us having another session to really focus on existing buildings and how we should tackle that in parallel with the Design for Performance initiative, the pilot projects that are focused on new buildings. I think that would be a really great thing for us to do and help to accelerate that reduction in carbon that we really need. So all I think remains for me now to do is to thank the speakers for all their great input and the questions from the audience that have come through. Sorry if we didn't get to them all, but we'll try and respond to those that asked a question that we weren't able to get back to. And keep a lookout. We'll try and come back to you with a session to talk about what to do with the existing buildings. Thank you.